So if I want to find the area of this middle triangle here, right? I have another square, right? I have 3 and 4, which is how much? 7. And 3 and 4, which is 7. So 7 by 7 would tell me how big, how much of an area would that be?
49.
49. So I'd have an area of 49 degrees. Or not 49 degrees, sorry. 49 centimeters squared, units squared, right? Cubic feet, squared feet, right? Because area squared. All right, but then what would that middle one be? So then I'd have to subtract these 4 triangles, right? So how many 4 triangles would I have?
4.
How many 4 triangles? What would each triangle be? How much would it be? So it'd be 3 by 4, right?
Yeah.
So 3 times 4 times 1/2, right? Yeah, it'd be 6. So it's 12 over 2, which is 6. So it'd be 4 of those 6s, right? So how much is the 4 6s?
24.
24? So we'd have 49 minus 24, which is how much?
25.
25.
25.
So that means this square area would be 25. So then how much would each side have to be if that's a square?
5.
Because obviously they're all the same size, right? So 1 times itself is 25.
5.
5. So then we found that this side has to be 5, 5, and 5. Right? Does that make sense?
Yes.
And that's the basis behind that Pythagorean theorem. Yeah, you kind of are. Because you're talking while I'm teaching. Okay? So, the Pythagorean theorem states a squared, right? Or in essence, a times a, right?
Yeah.
Plus b squared, or b times b, is equal to
C squared.
c squared. So, you're going to use some patty paper to prove that this is true. That if you take whatever side this is, right, and a square from that side, and whatever side this is, it doesn't even matter how much it is, but you make it to where this is another square, right? And you make me another square on this hypotenuse, then you should be able to fit this inside of here and this inside of here, right? And cut and paste it so that they fit inside. Does that make sense?
Yeah.
So that's going to be what we're going to do, okay? To prove the Pythagorean theorem, okay? So, and that's what you'll do at home. That's why we're doing the video, okay? So at home, you're going to make the mess. But you're going to prove to yourself that, and then you're going to have it, you're going to bring it to school on Monday, right? The pieces that you cut in order to fit. And they don't have to, this is the cool part. You can fit them in here in a lot of different shapes. Like some people fit them in with triangles. They'll make a triangle and another triangle and stuff. But some people will cut strips. As long as you fill this shape up with these pieces and these pieces, no matter how you fill it up, it's a puzzle, right? These 2 squares should fit perfectly into this square. Okay? So your job is to cut it up into pieces that fit in there nicely. And then come to school with a project of 1 square, 1 red square on the back that has a blue square, or not necessarily blue square, but blue stripes or blue triangles or whatever you want to make in there. You can actually make any design you want, right? As long as they fit together to take up all the space. So you can be as creative as you want. You can make 1 star and another star cut out of the other piece and put inside that triangle into that. You know what I'm saying? Any way you want. I don't care. It can look as beautiful and as artistic as you want, or as lame and non-artistic as you want. Right? Just done. Right? So you can make it plain, or you can make it very artistic. Question?
So two of the A triangles fit in this square, or A and B? I mean, not triangles, squares.
No. This rectangle, or this square, and this square will fit in this red square. No matter what size this triangle is, as long as it's a right triangle. Okay? This side and this side that you make out of green and blue, you'll be able to cut up any way you want, and you can fit, all of these pieces will fit into this piece. It'll fill it perfectly. And you can make any kind of design you want. That's the cool thing. If you're an artist, you can go in there and create this huge design with flowers and dragons and all sorts of things. Anything you could think of, right? Anything that you can cut. Because then all the pieces that you cut out are going to be placed elsewhere in the design, right? In the negative space. Nothing will overlap. Correct?
Right.
You can't overlap a green with a blue. That's the challenge. Okay? So the challenge is twofold. Right? I'll give a prize to the person who has the most artistic or interesting development.
I'll just do
Right?
a portrait of Natalie in every single one.
See? And hey, it might be a tie. You guys, I'll let you guys vote on it though, right? You guys can vote on which one it seems to be the most artistic, and if it turns out to be some kind of like contest between popularity, then I will choose, because I don't like popularity contests. I want it to be a true artist contest. Does that make sense? But it has to be a real proof. Does that make sense? It has to be a real proof. Just like our 2-column proofs are real, right? This is a proof. You are proving that this square plus this square fit perfectly, not kind of, perfectly into the red square. Okay?
Yeah.
And you have the video. I'll upload the video so you can watch it again. Any questions on that?
No, I'm good.
Okay? They fit perfectly. Remember, anything you cut out has to fit inside another cutout. Does that make sense?
Yes.
So if you cut out a moon, that moon has to fit into another cutout of a moon. So you're going to have 2 moons somewhere doing something. Maybe one's a moon, maybe one's a basketball. Who knows? Right? Okay. Cool?
Yeah.
All right.